table B right here. So the row number and the number of triangles in each row. All right, so this time we're adding 2. So here we had a 1, we had a 3 for our first term, first term, second term, and then our third term we had 5, and then we had 7, and now we will have 9 if we add 2 to the previous terms. So that means that if we add 2 to the previous term, so term 6 is what we want to solve. Term 5 was 9. So if we add 2 to this previous term, which was 9, we are going to get 11, or sorry, hold on, table B, 1, 3, 5, 7, 9. Good, we are going to get 11. If we look at term 7, add 2, we are going to get 13. Next we have table C. Now table C was the table that we were looking at when we were talking about Pascal's triangle. So with Pascal's triangle, you can go back to the first page, but the first numbers that were already given to us were 1, 2, and 4. And remember that each sum of numbers in each row would be doubled. So that means for the first, or for the fourth term, we would have 8. Fifth term, we would have 16. Sixth term, we would have 32. And our seventh term, we would have 64. So the next term can be calculated by somewhere we were multiplying. So multiplying the previous term by 2. And so that means that if we look at the 8th term, all we got to do is determine what our 7th term, which was 64, and multiply that by 2. So that would give us 128. Our 9th term, if we multiply 128 by 2, would give us 256. All right, so I would encourage you to fill the rest out by yourself, and then show me in class if you're having difficulties with these particular examples. But yeah, once you fill these out, then yeah, you should have the hang of how sequences work. But we're going to move on and just talk about the different types of sequences that we can have. So right now, we're only going to discuss 2 different types of sequences. We have arithmetic sequences, or arithmetic sequence, and geometric sequences. So our arithmetic sequences, or arithmetic sequences, are ones that every additional term you're adding a constant integer, or you're just adding a constant, and that can be either positive or negative. So when we were talking about the temperature in Calgary, we started at 8 degrees Celsius, and every term, or every day, we were going to subtract 4 degrees. So that's my first term. If I subtract 4 degrees, I was at 4 degrees Celsius. For the next term, my third term, if I subtracted 4 degrees, another 4 degrees, I would be at 0 degrees Celsius. And if I continue on with that same pattern or sequence, then I'm eventually going to be at negative 8 degrees Celsius on the 5th day, which we looked at. So this would be an example of an arithmetic sequence where everything happened by adding or subtracting a positive or negative integer. Next we have geometric sequences. Now the geometric sequences would be an example of Blaise Pascal's triangle. So Pascal's triangle, where each time we were multiplying the sum of the numbers in the rows, that would be an example of a geometric sequence, where we're not adding a constant value, but we're multiplying the term by a constant value. And again, that can be positive or negative. All right, so those are the 2 sequences we're going to focus on, and you're going to need to be able to classify them based on the constant term you're either adding, subtracting, or multiplying the sequence by. All right, next we're going to look at sequences as functions. So what you need to do here is with the tables from page 5, I believe it was, or sorry, no, page 3. So on page 3, you need to look at those tables and then take the information from the tables and put them onto the graph. So I'm going to do table A and table C for you, and the other ones you should be able to complete yourselves. So with table A, I'll just have it up here as well. So I'm using this information to fill out table A. So my term n is going to be my x-axis, my Tn is going to be my y-axis. So at 1, I'm going to be on 3 on my y-axis. At 2, I'm going to be at 6 on my y-axis. At 3, I'm going to be at 9 on my y-axis. 4, I'll be at 12. And 5, I'm going to be at 15. So what they want us to determine is, based on this information, these data points, which end up being our domain and our range, we want to determine whether or not it's a linear or a nonlinear function. So a linear function, is it going to be a straight line? Is it a sequence that is a constant addition or a constant multiplication? So table A, this would be linear. It forms a straight diagonal line. And now we're going to look at table C. So table C, if you recall, that was on Fibonacci sequence, or there was a Fibonacci sequence occurring there, but it was Blaise Pascal's triangle. So I'm just taking this information and I'm putting it into my table. And I'm just going to fold that up so you can see where I'm getting this information from. So again, this is going to be my x-axis, this is my y-axis. So n is my x-axis, so at 1, I'm going to be at 1. And so from 0 to 8, 1, this would be 4 here, so 1 is going to be somewhere around there. Next, at 2, I'm going to be at 2, and so 2, if that's 4, that's going to be about half. So it's going to be right about there. And 1 I could have had a little lower. Next we're at 4. Next we're at our third term, which was going to be at 4. So that's about halfway up my y-axis from 0 to 8. My fourth term, we are going to be at 8. My fifth term will be at 16. My sixth term will be at 32, and my seventh term, we're going to be all the way up at 64. So if you look at my plot here, and this should be a little bit lower down there, we obviously do not have a linear graph, right? It doesn't form a straight line in any way. This is an example of a non-linear graph, and we are actually going to classify it later on this year. All right, so for table B, D, E, and F, you should be able to fill those out from the previous charts. Now, circle the correct alternative in the following statements. This is the example number 4. So a sequence in which the next term is determined by adding a constant to the previous term. So if we look at our graph and compare the two, table A and table C, with table A, that was the card question, right? Every time we were